Hi everyone. Okay, I'm on the Wikipedia page looking at Klystron. This is a specialized linear beam vacuum tube invented in 1937. So, it's an amplifier for high radio frequencies. Okay, so when you look at Klystrons, then this will also lead you to Gyrotrons, Synchrotrons, and all these other kinds of devices that can focus electronic or electron beams and look, interacts with radio waves as it passes through resonant cavities. So I just want to tell you how powerful these things are. Okay, look down here. I mean, you have to study this. People who study, who are electrical engineers, they probably can understand this quite easily. But down here, I want to show you about the tuning of one of these. Some Klystrons have cavities that are tunable. By adjusting the frequency of individual cavities, the technician can change the operating frequency, gain, output power, or bandwidth of the amplifier. No two Klystrons are exactly identical, even when comparing like-part model number Klystrons. Now that's amazing. No two are alike. Each unit has manufacturer's applied calibration values for its specific performance characteristics. Without this information, the Klystron would not be tunable properly and hence not perform well, if at all. Okay, now listen to this. This is so amazing. So they have to tune the Klystron, right? Tuning a Klystron is a delicate work which, if not done properly, can cause damage to equipment or injury to the technician due to the very high voltages that could be produced. The technician must be careful not to exceed the limits of the graduations, or damages to the Klystron can result. Other precautions taken when tuning a Klystron include using non-ferrous tools. Some Klystrons employ permanent magnets. If a technician uses ferrous tools, which are ferromagnetic, and comes too close to the intense magnetic fields that contain the electron beam, such a tool can be pulled into the unit by the intense magnetic force. At first I thought this said, such a fool can be pulled into the unit by the intense magnetic force, smashing fingers, injuring the technician, or damaging the unit. Can you imagine the force of this? Special lightweight, non-magnetic, aka diamagnetic, tools made of beryllium alloy have been used for tuning U.S. Air Force Klystrons. Precautions are routinely taken when transporting Klystron devices in aircraft, as the intense magnetic field can interfere with magnetic navigation equipment. So what if they put these on airplanes on purpose to bring down an airplane? Special overpacks are designed to help limit this field in the field and thus allow such devices to be transported safely. Do you realize what a dangerous world we live in? Okay, so there's a lot of other information down here about Klystrons. And then if we go to, okay, look, crossfield amplifier, electromagnetic radiation, free electron laser, linear accelerator, magnetrons. Okay, that's what they do have, magnetrons at CERN. And remember that this was invented in 1937. So, okay, invented in 1937. So what I'm trying to say here is that all of these Klystrons, Gyrotrons, Synchrotrons, magnetrons that have been developed with these intense magnetic fields and capabilities coincide exactly with the advance of and what we see with crop circles. So, and not only that, with cattle mutilations and those kinds of possible experiments, I really don't think that these are ETs. I think that this is technology right here on Earth, and these things are pretty crazy. Because, you know, if all of these countries are dealing, Japan, they're all over the US, they're all over France, you know, there's the, well, let's go, I can't remember everything. Let's go here to the Gyrotron. Okay, here's a Gyrotron invented. When was it invented? Some early, okay, electron gun. Okay, we go down here to Cyclotron. Then we come to the Synchrotron. Okay, this was invented in 1934. So they have all of this powerful, powerful inventions and machines, or whatever you want to call them, that can deal with and influence the electrical field. And of course they're going to experiment, and if they want to do experiments with focusing and beaming this kind of energy, just like we have lasers now to use for good, you know, like laser surgery and things like that, wouldn't they want to experiment with size and shape and do fun things with it? And why not make crop circles? So people who are expecting, because they found microwave radiation in crop circles, and they're hot, and they, you know, they can do things to the plants. So people who go there and think they have a spiritual experience, this is from science, in my opinion. Okay, so here's we have a synchrotron, and then we have the synchrocyclotron. Okay, particle energy, the radio frequency electric field. Oh my gosh, and look at this. It's varied to compensate for relativistic effects as the particle's velocity begins to approach the speed of light. So this would take quite a lot of study to kind of grasp this, all of it. Okay, here's part of the former Orsay synchrocyclotron. So what if all these sort of clash? You know, somebody's pointing their cyclotron or their klystron in one direction, and then somebody else, and they actually intersect. Okay, then what about the tokamak? Okay, down here we could go to the, okay, wait, advantages, usage. For several decades, cyclotrons were the best source of high-energy beams for nuclear physics experiments. Several cyclotrons are still in use for this type of research. The results enable the calculation of various properties such as the mean spacing between atoms and the creation of various collision products. Subsequent chemical and particle analysis of the target material may give insight into nuclear transmutation of the elements used in the target. Cyclotrons can be used in particle therapy and to treat cancer. Ion beams from cyclotrons can be used as in proton therapy to penetrate the body and kill tumors by radiation damage, while minimizing damage to healthy tissue along their path. Okay, so Notable examples. Okay, one of the world's largest cyclotrons, excuse me, is at the Riken Laboratory in Japan. That's probably Riken. Called the SRC, superconducting ring cyclotron. Okay, so actually, okay, look, beamline. Where is the tokamak? It's here somewhere. Okay, I'll just type it up here, the tokamak. It is related, okay? Tokamak. So all of these are powerful energy producers. Okay, here's Wikipedia, tokamak. A device that uses a powerful magnetic field to confine plasma in the shape of a torus. Okay, it's all about shapes and focusing, and you know, geometry is scientific, and the beautiful and gorgeous geometry in crop circles with devices like this, of course they could be made. Okay, tokamaks were invented in 1950s by Soviet physicists. So all of these devices, tokamak, Klystron, cyclotron, Gyrotron, Synchrotron, they're all invented before the 1950s. And crop circles started to happen in the 1970s. You know, a whole onslaught. Okay, here's the tokamak. Early fusion design, early fusion research devices. Okay, advanced tokamaks. Since about 1990, tokamaks were designed to operate in high confinement mode to reduce plasma and energy losses so they can focus things. Plasma disruptions, plasma heating, neutral beam injection, magnetic compression, radio frequency heating. Goes on and on and on. Okay, so this they're gonna produce plasma. Let me find that for you. In France, where they're building a tokamak, and it's going to start producing plasma in 2020. Tokamak fusion reactor. Okay, so you know the Bible says in Peter, I think it's 2 Peter, that this world will be destroyed by fire. And you know, the Bible says that everything on this earth will be burned up. You know, and the heavens will roll back like a scroll. Okay, so here, the tokamak is an experimental machine designed to harness the energy of fusion. ITER will be the world's largest tokamak with a plasma radius of 6.2 blah blah blah. Okay, I don't understand numbers really. Okay, magnets, vacuum vessel, blanket, divertor, cryostat. Okay, so you see what's happening? Crop circles are nothing, okay? They're just playing around, testing. That's my opinion at this point. So the crop circle, Switzerland, you see that it is just, this was in June 26th, I believe. June 26 or 29. Let's get the news. Ah, it's not there. All right, let's see if it comes up here. Here it is, right here. This is the new one, okay? It's like a spinning thing, okay? So some people have compared it to a fidget spinner, and you know, it's just a simple shape. There's just, think about what I was just showing you with all of these incredible devices that can focus energy. This is just, you know, this is nothing, okay? They just can create these designs with the computer, have some kind of program it, focus it, and there you go. And these sorts of devices were started back in 1937. This is incredible. And then probably before that, you know. Actually, I think that this crop circle was June 29th. Let's see. In Freiburg, Switzerland. There we go. There's a better picture of it for you. Alright, so it looks like any of those little components in a microwave device, or anyway. What do you think about this whole thing? I think we're just totally unaware of the incredible science and devices and machines that are so huge and so capable and so powerful that no one looks into this or realizes what they are capable of. And also, this crop circle looks really, it's really a bad one. The edges are not smooth, and it looks, this is probably a man-made one, in my opinion, because it just looks, it's not perfect like the real ones are. The real huge ones that are probably made by some laser beam or some kind of particle energy, something like that. I don't know. Let me know what you think, and let's not be dummies and gullible, okay? Thank you for watching my videos, and God bless everyone. Bye for now.